Now, in continuation to the previous lecture, that is the characteristics of simple harmonic motion. So, we are doing the velocity. So, what is velocity? We have already proved velocity is equal to r omega cos omega t, and this r omega is taken as velocity amplitude v naught into cos omega t. This r omega is taken as v naught or velocity amplitude. Now, you will find the relation between velocity and displacement. Relation between velocity and displacement v and y. So, what is y? We know that y is r sin omega t and v is r omega cos omega t. This one. Now, we have to find the relation between v and y. So, change this, convert this cos omega t into sin omega t. So, we may write this cos omega t as 1 minus sin square omega t. You know that sin square omega t plus cos square omega t is equal to 1, and from here we can get the cos square omega t is equal to 1 minus sin square omega t, and square root of 1 minus sin square omega t is cos omega t. So, I have converted this cos into sin only to put the value of y. Now, put sin omega t from here. So, from here the sin omega t is y upon r. So, it will become r omega into 1 minus y square upon r square, because sin omega t is y upon r. So, this is velocity. Now, on simplification, v is equal to r omega into this under root of taking LCM, that is r square minus y square upon r square, this one, or r omega into r square minus y square over r square and root r. R will cancel with the r, and finally we got this one, relation of velocity. So, this is the relation of velocity in terms of displacement. So, we can discuss the special cases for velocity in SHM. So, special cases for SHM. First case, at mean position. So, what is mean position? It is a position when y is equal to 0. Y equal to 0 means no displacement. Then the particle is at mean position, that is this one. If we consider the example of simple pendulum, so this is the mean position and it is extreme position 1, it is extreme position 2. So, at mean position this y is 1, and after that y will increase. So, when y is 0, then velocity become omega into r square under root of r square minus 0 square 0, that is r square means omega r. So, this is velocity. So, velocity is maximum at mean position. You know that when this particle is moving at this point, it will move faster as compared to the other points. And the second case, at extreme position. So, these are the extreme positions E1 or E2. So, may this E1 or E2 be the extreme positions. So, what is the value of y? at this position, so y is r. If we go from this side to right side, it will be plus r, and we move in right side, it will be minus r. So we can take its magnitude, y is equal to r or plus minus r, both values. So putting the y is equal to r in the formula of velocity is equal to omega into r square minus y square. So when put the value of y as r, we will get this r square minus y is r, means r square again. So r square cancel out and it will be 0. So as at extreme position 1 or 2, this velocity become 0, because when you put the value y as plus r, again we will get r square, and when we put this minus r, so square of minus r is also r square. So at these positions, these are positions where velocity is 0, and at this position velocity is r omega, that is maximum, or v naught. So these are the special cases for velocity. Now the third characteristic is acceleration. So what is acceleration? You know that acceleration is the rate of change of velocity with time. So we know the value for velocity is r omega cos omega t. The value of velocity is here, which we have already proved. So putting the value of v in this equation, we will get a is equal to d dt of this velocity, that is r omega cos omega t. And what is the final value? This r omega is constant, so we will take it common from the derivative. It is r omega, and the derivative of cos omega t is minus sin omega t into omega. So it is minus r omega square into sin omega t. This is an acceleration. So this is formula for acceleration. So again we will derive the relation between A and displacement. The relation between acceleration and displacement, as we have already proved, the relation between v and y. So it is the relation between A and y. So we know that A is here minus r omega square into sin omega t, and y is, we know that y is r sin omega t. So this r sin omega t can be put as y. So it is A is equal to minus omega square into y. So this is the relation between acceleration and displacement. So you have already read this formula, or you are familiar with the formula. A is equal to minus omega square y, or this minus and omega square is taken as constant. So we may write it as proportionality constant. It is equal to, it is constant, so both will comprise proportionality. So A is proportional to y, or acceleration is directly proportional to displacement. So this is the main condition for the particle which is moving in SHM. So this is the main test or main formula for SHM motion. So this is acceleration, and we have the formula acceleration is minus omega square y. So we can discuss again at mean position. At mean position, that is taking y is 0, so acceleration is 0, means at this point acceleration is 0, and at extreme positions y will be taken as r or plus minus r. So we will consider it at y is r, then a is equal to minus or omega square into r, or by taking its magnitude we will consider only its magnitude or value. So we will get this a is equal to omega square r. So what is this omega square r? It is the maximum value of acceleration. So this is all about acceleration. Now next, time period. You know that when the particle is moving in simple harmonic motion, means which repeat itself after a fixed interval of time, that is SHM. So it must have a time period or frequency. So fourth part is time period. Time period, that is capital T. So what is the formula for capital T or time period? So we will use the relation for acceleration, that is acceleration is a is equal to minus omega square y, or we will use its magnitude, or a is equal to omega square y in magnitude. So from here this omega square is equal to a upon y, or omega is equal to a upon y under root this one, or a is acceleration, y is displacement. You also know that this omega is 2 pi by t. You know that omega is 2 pi by t. So putting the value of omega as 2 pi by t, so this is 2 pi by t is equal to under root of a over y, and t become this 2 pi and under root of y upon a, because t will move from the denominator to numerator on right hand side and it will go on the left hand side, so y upon a. So this is formula for time period, that is 2 pi under root of y means displacement over a means acceleration. So this is formula for time period. So next, fifth part is angular frequency or simple linear frequency. Means frequency, we can calculate the frequency of the particle which is moving in SHM. So frequency is the number of cycles, number of vibrations per second is called frequency. So frequency, simple frequency, you know that frequency is denoted by nu, and we know that nu is a reciprocal of time period. So when we put the value of time period here, this nu become 1 upon this 2 pi and this y upon a. So frequency is 1 over 2 pi into a upon y. This is frequency. Or angular frequency, it is nothing. Angular frequency is simple omega, and omega is 2 pi nu. So omega become 2 pi into nu. Nu means this 1 upon 2 pi into a over y under root. This 2 pi will cancel the 2 pi and omega become under root of a upon y. So these are the characteristics or formulae which we will use in simple harmonic motion. So next, in the next lecture, we will discuss the different types of simple harmonic oscillators. So we will discuss nearly 4 oscillators in the next topic, in the next chapter. Thank you very much.